I've seen it before. Go ahead.
Oh. I just wanted to go look for that one. And I'm going to put that up.
So what did you put in the bottom, Mrs. Byrne?
Potassium chlorate.
Okay.
And where am I supposed to? So I'm going to just sort of melt that. You get it nice and warm. They're touchy with our hood. Come on, guys. Our hoods suck out our flames a lot these days.
You know?
Yeah, it doesn't want to strike. I had it lit. It doesn't want to. Well, that's not normally the problem. So what I'm going to do is just heat this up and turn it into sort of a melted condition. And then someone liked to get me one of those. They found these in the container over there. If you give me one of those sugar things on a tongue, please. The whole idea here, now you can do this with gummy bears, that's why it was called a screaming gummy. The idea here is that the sugar we're going to oxidize the sugar of what's in this very rapidly. What we're using here is just the energy of what you see in the sugar that you see there. So we're actually taking all the sugar, oxidizing this down to real carbon as we're going on this. It's called the screaming gummy because if this had been a gummy bear, you see it sort of howling as we're making that sound with it. The problem I do have with this particular one, sometimes when I'm doing this gets so hot it will break out the bottom of the glass. That's why there is a horrendous amount of energy in any sugar that you're eating. So this is why I was showing you this particular one. We can do the same thing with Cheetos or anything else anything that has a sugar base of any kind you can throw into this particular reaction. Okay, questions about that one?
All this energy from the sugar?
It's just energy from the sugar. You don't think? I know, but you get a lot of energy out of it.
I get so much sugar.
Yeah. Well, that's where it's coming from. So a lot of energy out of that sugar.
17 kilojoules?
Yes, that's what we're talking about. And you really get a lot of energy out of any sugar that you're eating, and it goes through that. With an oxidizer, you can oxidize it fast. And so potassium chlorate is kind of a dangerous substance because it will oxidize so fast.
Can you do these experiments with something other than sugar, like
well, the whole idea here is to use the sugar as the energizer for it and to oxidize it. Lipids are harder to do in this fashion, in the way that I'm doing it here. You can. They tend to melt and do other things, and so they don't provide this kind of energy that we're looking at in sugar.
So what does it end up producing at the end?
Well, you can see how black this has gotten. We have a whole lot of carbon, and when you look at sugars, it's glucose itself is C6H12O6, and so you have the water coming off, and you're left behind with the carbon. I think that's the whole thing.
Is oxidizer as in redox reaction? Or
Yes.
is it just
This is really providing lots of oxygen to get the reaction to work. That's what you're doing there. Because, see, when you do a normal oxidation, even if you burn it or something like that, you have the carbons and you add the oxygen and you get water and carbon dioxide. Well, the problem with that is you need more oxygen to get it as reactive as they got here. And so the potassium chlorate adds enough oxygen to it that I get a great reaction while I'm at it.
Does this mean we substitute sugar?
That would be interesting to try. I've never tried that. That I don't know, but there again, it's the structure of that carbon chain. It might. Depends on what the structure looks like. That's an interesting thought. We should try that. Okay, very good thought. Okay, any other questions, anybody? Thank you for coming today.
Thank you, Mr. Burke.
Sure.